Hi guys, in this video we will draw the shear force and bending moment diagram of this truck, the movable truck on a bridge, and we will be using this mobile app SW frame to get the results. So first of all, you have to come to your Play Store, in the mobile or your laptop. So in the Play Store we will search for the SW frame. So upon searching we will get this app SW frame. So click on this and install. So I have already installed this app, so I will just click on open. So upon clicking we will be getting the interface as that. We have to draw the shear force and of this same truck. You can see this 32 and 32 kept 2 axles loads and 8 kept third axle loads. So as can be seen, this is 32, this first and second axle, and this is the 8 keep load, and we will be verifying this the results with this theoretical calculated results of both shear force and this bending moment diagram. So upon opening you will get the software, you will get an interface like this. So first of all, you have to select the units to make consistent with the units. So we will be using kip for force and the feet for the length. So click on this icon and you will get this menu and interface. So we have to click on this settings, and in the this settings you will get the different units. So for the length we have to click on this and choose the force system, and similarly for a cross section area you can select this and use the inch square, and for the elastic modulus of elasticity you can select this KSI. The force which is necessary to maybe the kip, so we can select the kip, and the unit weight will be kip per cubic foot. So this will be the force unit, and in the drop down menu, the displacement will be in inches. So upon this upon selecting these units, we have to come this back into our app. And the first things we have to assign our nodes. So this will be the first node. We will define this over the first node, and this will be the second node. So we will select, as you can see that the length of the beam or the girder is 35 feet, as can be seen here. So we will click on this, and then we have to specify a location for our initial position. So you can see this is the zero grid system in the y and x direction, and this is the zero, and this is upon intersection of this zero and this zero grid. So here you should just select on this grid, so we can get the first node. You can see this is the can you see it? So this is the first node. You can be seen as we have defined this. This is the first. So upon clicking you can select the first, and the second, this will be the second node. So this will be the second node. So this can be seen is from this figure. You can see this is 35 feet. So we have to come here and we can select it. This is 35 feet. So our first node at the zero, as can be seen, 0, and this is the second node at 35 feet. So we have to click on this node and then click the point where we want to draw our second node point. The next thing, so we have to define this frame or beam. So we will click on this, and upon this we can select on the first option is add frame element. So we will select our first one, and then we'll select our second one. So our beam has been drawn. The next thing, so we have to define the loading. So as can be seen, this is like the truck, the same truck. This can be seen is this 32 kip and this 32 kip and this 8 kip. This is the loading. So in this figure we can see, so we can see this. This is the first load, axle load, 32 kip, which is 3.5 feet away from this first node. So first we have to select on this arrow to define a node, a point load. So in this point load, so and this click on this, and we will select the beam. So it will ask for the location from where the first load is. So as you can be seen, the first 32 kip load is 3.5 feet from the first node. So we can select at the distance of 3.5 feet, and the magnitude of this load is can be seen. This is 32 kip. So we will in the load we will type 32 kb, and then we can click on save. So our first load has been defined 32 kb. The next load we have is the same 32 kb, as you can be seeing. So this is 32 kb. Actually the truck in this direction is actually the reverse, so but the loading is the same. It is again 32 kb, which is this load. So this load is from this distance, it is 14 feet plus 3.5, which is equal to 17.5 feet. So we will again in this section we will click on this arrow, and then we will select on the point load. Next we have to click on this beam, and upon this clicking we will get this menu. So the distance from this initial point is 17.5. As you can see, like from this node to this distance is 17.5 with the same 32 kb load. So in the load we have to select 32 kb, and then we have to click on save. So we have defined the two loads. The next the last load is this 8 kb, which is 14 and 14 from this node, from the node it can be seen it is from the this 8 kb is 14 and plus 14 28 and 3 31.5 feet. So from this distance is 31.5 feet. So you will click on this arrow, and this on the point load, then we select this frame, and then we can just 31.5 feet, and the load magnitude is 8 kb. As can be seen, this is the 8 kb load, and we will click on this and save. So we have defined the loadings. The next thing we have to assign the supports. So we can assign the both supports as pin supports. So we will click on this option, and then we will select as a pin support or hinge support. So we will click on this, and next we have to click on this node. So the support has been assigned to it. We have to assign another pin support to this end. So we will click on this option, and then we click on the hinge or pin supports, and we will click on this end to get our supports. So here is going to directly give the result. So to first of all we can see here the manual. This is the reaction, and this which is 46.5, this vertical reaction, and this is the reaction is this is 26.4. So as you can see from here the results, you can see like the 45.6 kb. This is 45.6 kb, and this another will be 26.4, and this is the 26.4. These are the reaction values. The shear force diagram we can get on upon this in this section. You click on this, and then we'll click on the shear force diagram. So we can see from here, this is the shear force diagram. As we can see in this support, the shear force is the 45, and this which we can show this is the 45, and this under this load, this 45 gets dropped to 13.6. Actually the sign convention is reversed if you want to get like the same in this one. So we have to click on this, and then on the settings, and this option we can compare. This is the same, but actually the direction is opposite. So you can see this is 45 and 45, and this we will get here is 13.6. as can be seen, it's 13.6, and this will come to 18.4 and 26.4. So as you can see it's come to like 13.6, 18.4, and then ultimately it come to 26.4. The bend to movement diagram we can get upon clicking on this, and we can click on this in a bend to movement diagram. So the maximum bend to movement occur is 349.95, which can be seen 350, which is almost approximately same as a 350 foot kb. This can be seen as a 350 kb foot. Under this point load, you can see the bend to move here is a 158, and we can see here this is almost a 159, which is almost same as the 158. And under this 8 kb load, we can see here the bend to movement value is 92.4. As can be seen here is the same 90.56. So this is almost approximately the same. If you want to get the more results, so we can click on this, and we can get on the slope. It will give the slopes as well. and this we can get the deflection at the mid, which is the convention of the drawing is opposite. So you can see here the deflection at the middle is 9.7 inches. We can get deflection scale. Actually this is in the real direction, so the deflection here will be the maximum under this metal. It will be 9.7 inches, and we can get deflection at these loads, under these load as well. We can get on this on a free body diagram. So actually if we can see here is only one member, so we select on this one member. This is the reaction values we can see here. So in this way we can click on this, and if you click on this option, and you can just generate reports. It can give the report in the PDF form as well. So this is how we have the analyze. You can see this Android app is very useful for the structure analysis. You can analyze any type of beam or the frames or 2D frames, any option with this app. So this is a very cool app, and you can download and try this. I hope this will be helpful for the today video. So thanks for watching.